So after constructing the structural system with especially customized tunnel form, all you have to do is you have to have filler walls, and those filler walls can be partition walls, it can be outer walls of the tunnel which you have created with the casting of slab and shear walls together. And in this project, autoclaved aerated concrete blocks, which are lightweight precast concrete blocks, are being used. And these lightweight aerated concrete blocks make use of cement, lime, gypsum, and fly ash, and they are being light in weight, density being 800 to 1000 kg per meter cube. They are used for non-load bearing application for filler walls as well as for partition walls. And as you can see here, their size is more than the size of a brick, and they can be laid pretty fast. And being made of foam concrete, they have excellent thermal insulation properties, and being light in weight, they bring economy in the overall cost of construction. So this was about the structural system. So in this lighthouse project at Rajkot, the structural system primarily comprised of shear wall construction, which is done using tunnel formwork, and non-load bearing walls are of AAC blocks. So the advantages, if I need to dwell on advantages, it facilitates rapid construction of multiple mass modular units. So this can also be a limitation, because you need to have multiple or modular units. If you don't have modular units, this tunnel formwork won't be suitable. So it will facilitate pretty rapid construction. And as I told you, in the lighthouse project at Rajkot, the company is claiming to do one floor in one day. Being without joints and doing the pouring in a single day of column of a slab and walls together. So this is a durable structure because there are no leakages and there are no joints. The structure is monolithic. So in the long run as well, it requires low maintenance. And as you saw, because it is being done with tunnel form, which is of steel, pre-painted steel tunnel form work, so it gives you finishing which is so good that you don't require any plastering, and you can just do away with the putty and the paint. It's a primarily it's a shear wall construction comprising of mass concreting and reinforcement. And here for concreting, the part of cement is being replaced by fly ash and GGBFS, which is ground granulated blast furnace slag. It is a byproduct of a steel industry. So the concreting, the concrete being used here in a way can be called green concrete, because part of the cement is being replaced by fly ash, which is again an industrial waste, and GGBS. And GGBS being very fine particles, it gives it improves workability and durability, and at the same time give you a structure which is non-permeable. Also, as I've been telling you, that this is a monolithic concrete construction, and monolithic concrete construction is also known with the name box type structure. And whenever we do any construction in a seismically prone area, we need to ensure box type action. So this monolithic concrete construction or this kind of tunnel formwork, ensures box type action, which is very good for structural integrity against horizontal loads, primarily earthquake loads. And because you are doing multiple units and you are doing it very fast, and you are doing it with formwork system of this kind, the large number of modular units bring economy in the overall construction cost. As far as the limitations are concerned, first of all, because you need to, as per your project requirement, you have to give the order to a factory for manufacturing this tunnel formwork. So a minimum lead time of 3 months is required, but this lead time can be utilized to cast your foundation, because if foundation is conventional, so the activities can go concurrently, so that way you will not waste any time when you are doing foundation. At the same time, your the formwork is being manufactured in the factory. So that lead time can be recovered by doing the work at the site by laying foundation and other thing. Secondly, because it's a monolithic concrete construction, so you have to lay all the services properly beforehand at the time of construction. So post-construction alterations are difficult to do, as all service lines are pre-planned. Economy in cost is achieved with large number of multi-story. So there is a kind of critical mass. If you have that critical mass, then only you will get economy, because otherwise the cost, it may be a costly affair. So minimum 500 to 1,000 dwelling units if you have, then you can achieve, then the project may become viable and you may achieve economy in cost. So these are few limitations. But as regards the other form of tunnel formwork, which is aluminum formwork, where instead of tunnel you make the entire house using the aluminum formwork, there the technology is already mainstream and it is being used in India, and economy is being achieved even for houses less than 500. So once the technology is mainstream, this large number of multi-story units are not required to make the project viable. Now, this kind of projects, because there we are using the new technologies, the project is awarded on design and build basis, and design and build basis means the project is given on a turnkey basis. So these specifications are given to the agency along with the sizes of house, layout, and the plot, and then agency is being asked to design the structure, submit the structural design along with architectural drawings, and then those designs need to be vetted, because the new technology, so there is a check and balance in terms of vetting of design by some academic institutions. So here in this project, the design is being vetted by the NIT Surat, and once the vetted design, based on that vetted design, the good for construction drawings are released to the agency, and then agency start the work. So for this project, the tunnel formwork is being supplied by Utinart Formwork System. It's a French technology. It's a new innovative construction system, and Malani Construction Company is the contractor for the project. So let me just now tell you about the design basis, because for designing, for doing the structure analysis and design, first and foremost thing is design basis report and finalizing the design parameter. So if you want to have a look on the design parameters, it's a steel plus 30 structural configuration. So that is, and the height of building from the ground is 43.1 meter, and typical floor height is 2.95 meter, and it is all these things are complying to the local bylaws and local municipal laws. Parking height is 3.55 meter, and the plan area of building is as per architecture layout. Then depending upon the dead loads which are considered, dead loads can be considered based on the density, and these densities are given in IS 875 part 1. From where you can take the densities and calculate the dead load. In addition to dead load, depending upon the users of building, you can have the live load. Live load for residential building is 150 to 200 kg per meter square. So here you can see, as per 875, live load is being taken, and then the other details here, as you can see. Floor height, the dimension of the building, grade of the concrete, because it's a monolithic concrete construction and it's typically a shear wall slab construction. So high strength concrete M40 is being used for walls, slabs, and beams, and for foundation M25, slightly lower grade concrete is being used for foundation. The grade of steel being used is Fe 500. TMT bars are being used, and in addition to the dead load and live load, the other loads which may come on the building, such as water tank load, the load because of lift, all these loads need to be accounted for. So in a design basis, primarily comprises of design parameters, where each parameter which is crucial need to be first put in this design basis report, then need to be checked, and then only analysis can be done. Then once you have calculated dead load and live load, then you have to calculate the wind load as well as your earthquake load. So the wind load, for wind load, this is the wind hazard map for the entire country, and this map has been taken from Vulnerability Atlas of India, being published by Building Materials and Technology Promotion Council. And this map primarily is based on the wind map given in National Building Code 2016. So depending upon the location, because this is a Rajkot, so in Rajkot the basic wind speed is, as you can see, this blue thing, this is a 39 meter per second. So this is a basic wind speed, which is then modified to calculate design wind speed, and it is multiplied by several factors depending upon the topography or size of the building, the importance factor, and when multiplied, there is a code IS 875 part 3. So you get the design wind speed, and then that design speed can be converted into wind pressure by this empirical formula, which is given again in IS 875. And having calculated wind pressure, that wind pressure can be multiplied by with the area, and then can be put as a horizontal load on various story of the building. And once you have that load in combination of dead load, live load, and earthquake load can be put for structural analysis to get forces on various structural elements, and then accordingly the building can be designed. So that was for structure. And for the foundations, all you have to do is you have to carry out the detailed geotechnical investigation and find out the safe bearing capacity. And once you know the safe bearing capacity, you can decide the kind of foundation you require. So here the safe bearing capacity is 25 ton per meter square, and based on the subsurface investigation, you also arrive at the depth of foundation. So depth of foundation here varies from 2 to 2.5 meters, and based on that safe bearing capacity, raft foundation is being designed by referring to IS 82950, which is the code for the design of raft foundation. And as I told you earlier as well, the minimum concrete grade used for raft foundation is M25. So for the substructure, we are using shear wall, we are using raft foundation, and over that raft foundation up to plinth, shear walls are being erected. And these shear walls are done in the conventional way. Once we reach at the plinth level, then at plinth level, all the shear walls are connected together through a plinth beam, so as to have structurally integrated structure and to have a monolithic, to ensure monolithicity in the at the plinth level. And once you reach the plinth level, then dowel bars, which are left out in the plinth beam, which are coming from the shear wall, they are connected with the wall reinforcement. Then tunnel formwork is inserted, slab reinforcement is laid, and then the pouring is done. So the raft, which is connected to the plinth through shear walls, and those shear walls in the substructure are connected with the walls on the floor through those dowel bars, and these walls are connected with slab. So you get a box-like action, and entire thing is monolithically done without any joints. And infill walls are of AAC block massively. Then after calculating wind load, you need to calculate the earthquake load. India is a seismically prone country, and the entire country is divided into 4 zones, as you can see, zone 2, 3, 4, 5. And Rajkot, Rajkot, as you can see here, is zone 3, where the Z is 0.16. So from this is again a map from Vulnerability Atlas of India BMTPC, and this map is based on IS 1893-2016, which is the code for knowing for calculating the earthquake loads, and as well as for knowing the various earthquake zone. So as you can see, Gujarat, this Rajkot area has earlier experienced earthquake. There was an earthquake in Bhuj in 2001. So this kind of monolithic concrete construction with shear wall and slab construction is quite have excellent property as far as seismic resistance is concerned. And with the 1893, this is the formula which is given depending upon the zone, depending upon the importance factor of the structure which you are doing, and then you can calculate the response reduction factor, which depends upon the kind of structural the element you are designing. So here the structure is being designed as a dual system, and dual system comprises of ductile RCC structural walls and few special moment frames. So for this, the response reduction factor is 4. So these, again, all these things are given in IS 1893. There are tables, and depending upon that, those tables, and then SAB by G is a design acceleration coefficient, which is again calculated, from a spectrum, which is given again in 1893. And for that, you need to calculate the time period. And for calculating the time period, again, equation is being given in 1893. So easily you can calculate this design horizontal seismic coefficient, and this design horizontal seismic coefficient is multiplied by the seismic weight or the vertical load which is coming on the building to give you the base shear, or to give you the horizontal load for which you need to design your building. So once you get this base shear, that base shear is distributed depending upon the stiffness and mass of the stories at each story, and that way you calculate earthquake load at each story. So through this design basis, through these design parameters, we calculate dead load, we calculate live load, wind load, and earthquake load, and all these loads in different combination, again given in Bureau of Indian Standard, IS 875 and other codes. You carry out the analysis. So as you can see, this is the 3D model which is created in ETAP, SAFE. There are a number of softwares which are available: ETAP, SAFE, SAP, Abacus, StatPro. So in that, you can either create a 2D model or you can create a 3D model. And as I told you in the previous slide, having calculated those dead load, live load, earthquake load, and wind load, you subject your building to these so many load combinations. So there are 13 load combinations when you are considering wind load, and similarly there are 13 load combinations we are considering the earthquake load. And earthquake load, in each lateral direction it will act one at a time. So lateral forces shall be considered acting from all directions one at a time. So you have more than 30 load combinations for which you have to analyze your building. So analysis can only be done through a software, and there are umpteen number of softwares which are available. And the good news is all these softwares are now customized to suit to Indian standards. So straight away they can make load combinations for you. They can calculate the earthquake load, wind load, time period, entire thing for you. And all you can do is create a model and then carry out the analysis. Again, analysis can be static analysis, dynamic analysis, linear, non-linear, eigenvalue analysis. Any analysis can be carried out. Idea is to get shear force, bending moment, axial force, and torsional forces in all directions at each joint and for each structural components. And having done the analysis and having and getting those design forces, moments, you have to carry out the structural design. And for structural design also, now these softwares have provisions for a structural design based on the Indian standards. So because it is primarily a shear wall construction, concrete construction, so IS 456 can be used, and there are 2 limit states for which the design is to be done. So in addition to these load combinations, you need to satisfy these 2 limit states which are given in IS 456. And these limit states are limit state of collapse and limit state of serviceability. So create a model, first create a design basis report, calculate all the loads, create the load combination, create the model in any software, carry out the analysis. Through that analysis, for the worst possible load combination, calculate at each joint, each connection, and for each structural element, design forces, and based on design forces, you design your structure. And here, let me also tell you, designing means what should be the thickness of your wall, what should be the reinforcement in that, what should be the spacing of that reinforcement. So these are the design parameters, and nowadays through softwares, you can immediately design your structure, get the sizes and reinforcement details. And there is another software which is very important, to create a structural and architecture drawings. So as engineers and architects, we must have, we should not be proficient, but we should have knowledge of AutoCAD also, so that we can create drawings in AutoCAD and read those drawings of AutoCAD. So this is the model of the one tower of lighthouse project at Ranchi. So as you can see, this entire thing is modeled Yeah. Then, because it is primarily a reinforced concrete structure, so concrete mix design, because we are using M25 and M40, and the performance of the structure will depend upon the quality of your concrete and the reinforcement. So normally it is advised, it is recommended that we have to do mix design, and now IS 456 also recommends, the mix design for a higher grade of concrete. So through National Cement, National Council of Cement and Building Materials, Ahmedabad, the concrete mix design has been done. And as you can see, here they are adding GGBS, generated blast furnace slag, which is a byproduct of a steel plant, and making this concrete, green and sustainable. And through mix design, the advantage is all the quantity, all the quantities of these materials are optimized. So it becomes, the concrete mix design brings resource efficiency in your project. As you can see, water cement ratio is also minimized, and you're adding admixtures also for early gain of strength. Normally, when you do a large project, normally you have to put a batching plant. So this is the batching plant which is being put, and this is also one of the essential requirement when you use new technologies and when you're doing heavy concreting. So it's better to have a batching plant, because batching plant will ensure your resource efficiency and minimize the wastage of these precious materials which are based on natural resources such as cement, aggregate, sand, etc. And it is also of utmost importance to create a quality control lab at the site. So you can see a typically quality control lab comprises of compression testing machine, set of sieves, slump test, and other things. And this is also mandatory to have a quality control lab at the site, so that whenever you are doing the concreting, you cast few cubes and see the strength, because here you are using a high strength concrete, and we rely on early gain of strength at an early age. So it is very important to have checks and balances, and to put in force strict quality control and quality assurance measures. Okay, so ensuring the good quality and of concrete is must for this project. Now, having explained you the structural system and the various other features of the technology, now I will take you to the site and try to explain you the construction sequence through the work which is being done at the site. So construction sequence, again, as I told you about the substructure, superstructure, again divided into substructure, superstructure. So we will first see how foundation is being done, and then we will go to the superstructure, which is monolithic, shear wall, and slab. And then we will, in last few slides, we will show you how plumbing and electrical services are laid in this kind of systems. So as you can see, the first and foremost important thing is to read the structural drawings, and this structural drawing is just put for you to show you the structural layout at the foundation level. And you can, as you can see here, there are rafts of different thickness. Okay, so this is a raft which is 750 thick. So this is the one raft, and there is another raft which is being put here, which is 900 mm thick. So where the loads are less, then and here we are having staircase and lifts as well. So here the raft foundation is 900 meter thick, and it is 756. So this structural drawing is very important, which gives you which raft is required and what is the thickness of this raft. So accordingly, it has been they have been named. This is RFT1 is raft foundation 1, which is 750 thick. Raft foundation 2 is 900 mm thick. Okay, and there, wherever you have that staircase well or lift, there you put in addition to that, you put another 160, 150 to 160 thick cap over that. Okay, so this is how it is being shown here, and this slide also shows you over that raft what are the location of those shear walls, which will go up to the plinth level. So this is a raft which is coming from the ground, and once you have put this 900 mm thick or 750 mm thick that raft, over that you will put this shear wall, and this shear wall will go up to the plinth, and at plinth level all the shear walls will be connected through plinth beam. So these are the location of those shear walls. And as you can see, these shear walls are 200 thick and with a height of 4.40 meters, or somewhere it is 6.58 meters. Okay, so this is a structural drawing for foundation, giving you details of raft as well as shear walls which are coming below the ground. This is also very important because when you are doing a construction in a seismically prone area or in zone 3, 4, 5, you need to refer to the ductile code as well. And ductile, IS 456 and IS 13920, which is a ductility code, along with detailing there is a special publication SP 34 on the reinforcement detailing. That is very important because you need to connect the reinforcement of raft with the reinforcement of shear wall to have continuity at the joints and to have a ductile behavior. So this drawing typically shows you how the reinforcement need to be placed. So you can see this is the reinforcement of shear wall, which is coming down and it is going like this. And similarly, you need to ensure the continuity of the reinforcement of raft with the reinforcement of shear wall. So raft foundation with shear wall up to plinth level, as I told you. So this is a plinth level, and this is your raft, and over that raft, this is your shear wall, which goes up to the plinth level. And so what normally is being done, because the ground is normally undulated. So first PCC is being laid, and this PCC is normally it's a lean concrete, 1:4:8, and its thickness is around 100 to 150 mm. Here it is 150 mm. So once you lay, for leveling the ground, you lay the PCC, and over that you lay the raft. And that raft, as I told you, its thickness varies depending upon the location, 750 to 900 mm, and over that you put your shear wall. So over the raft you are putting a cap, and over cap that shear wall is coming. Okay, and the shear wall, the reinforcement, the concrete grade being used for shear wall is M40, whereas for raft it is M25. And all these shear walls, as I told you, are connected for monolithic action by plinth beam, and the size of the plinth beam is 230 to 600 millimeter. And again, the grade of the concrete used for shear wall is M25. So this is a typical detail, and this detail need to be referred time and again, so as to ensure ductile behavior even at the foundation level, or at the joint of foundation with the raft with the shear wall. And then this is also very important when you need to take this reinforcement continuous from the shear wall to the leave it as a dowel with which the reinforcement of wall will be connected. So this is again a picture, the photograph from the site. So first you have to do the layout, and after doing the layout, you have to carry out the excavation. As you can see, this is a rocky terrain, so a lot of difficulty to excavate the ground. And so you have to go to the required depth and excavate the soil. And for each block, and here mechanical excavators are being used up to the required depth. And wherever you have hard rock, you have to put extra efforts to excavate the ground. Okay, and this picture shows you that about that PCC. This is 1:4:8 PCC, because the ground may be undulating. So having excavated the ground, you have to lay this PCC, and over this PCC you will put the reinforcement cage and do the raft depending upon the structure design. So you can see this is your PCC. Once you have done the PCC, then you are putting the raft. And as I told you, the raft is being done blockwise. So somewhere the thickness of raft is 750. Somewhere it is 900, somewhere raft is with cap, and somewhere over raft only shear walls are coming. So you can see this is a typical photograph showing you how the reinforcement is being laid. So as you can see, the reinforcement, their spacing need to be checked, the continuity, all the the bars, reinforcement bars in both the direction need to be tied with the wire at each location. Then wherever there is a lap between the two reinforcement, because reinforcement will come of a specified length, so you have to join two reinforcement. So there you have to with the binding wire, and with this, you need to provide splices, you need to provide this development length as well. So all this detailing need to be done, and this need to be checked by the supervisor and by the structural engineer. And once you have laid the reinforcement, then you can do the concreting. So as you can see here, because it is a heavy mass concreting work, so through the pump and pipes, this is how the concreting is being done. And before doing the concreting, you have to cast few cubes, and those cubes will be tested in the factory, in the laboratory, and they will also be tested by the third party, so as to ensure that we are using M25 concrete, not less than that. Okay, so this is once you have laid the reinforcement, and as I told you, continuity of reinforcement is very important. So once you have put the reinforcement cage for the raft, at the same time you put the reinforcement cage of the shear wall, and then you do the concreting for this, and then later you do the concreting for this. But this reinforcement of shear wall need to be tied properly with the reinforcement of raft. And as you can see here, so this is how this is being done. So this is raft. Now here this concreting is going done, and after that you do the curing. Curing is also very important when you are doing mass concreting. So heat of hydration is very important. So you need to keep the the exposed surface wet through Haitian cloths. So you can put this kind of Haitian cloths and do the keep on doing the keep on watering this Haitian cloths, so as to keep this surface wet, so that you have a proper curing. Because if you don't have proper curing, there will be the cracks, shrinkage cracks, as well as other cracks, leading to leakages and leading to the failure of concrete at a later stage. So curing is also very important, and once you have done the curing and all, you can start doing this the casting of shear wall with formwork. And this is the formwork for shear wall which will be put now. So you can see here, this again, this is how, once you have done the raft, after that raft, you are putting the formwork for a shear wall. And after putting that formwork for shear wall, you do the casting, you pour the concrete in these shear walls, and these shear walls will go up to the plinth level. And after reaching the plinth level, you will do the backfilling. And once you reach the plinth level, you will connect all the shear walls through a plinth beam. So you can see here the reinforcement for shear wall is being raised, and then concreting is being done. Now, so this is that level I was talking about. So up to now this entire thing has been backfilled. So what you see is a plinth beam. Okay, so what you see is a plinth level, and over this you will do the plinth beam. And again, that reinforcement of shear wall is being continued here, and you will do the plinth beam here. And this reinforcement of shear wall will be connected with the reinforcement of the wall which is coming above. Okay, so that's how the continuity is being ensured. So plinth beam is constructed over shear walls. So these are those shear walls, and these are connected with this plinth beam. And this is the typical reinforcement of that plinth beam which I was telling you. It's 230 meter wide and 600 millimeter is the depth of that plinth beam. So this is the plinth beam, and this plinth beam reinforcement is also connected with this shear wall. So this is a plinth level, and then you do the plinth beam here. So this you can see here. So now the plinth beam has already been cast, and this is how it looks like. And now this is the wall. Over this, your the tunnel form will come. You will fill it up, and then do the concreting on a single pour. Okay, so this is again a view of foundation. And once you have done here we have reached the plinth. Now the plinth beam is finished. After finishing the plinth level, what you see is this kind of thing. So this is your backfilling is done here. So backfilling is being done, and what you see is here, and then after that you lay the floor, and then start erecting start doing the wall and slab together. So this is how it looks like. So whatever I explained in the previous slide, that has gone below the ground, so that is called substructure, where you had raft and those shear walls, and these shear walls are connected at this level by that plinth beam. Now you can see here, this is a structural layout. Again, plinth beam, the depth, how it is connected to the walls above and below, that all is to be seen from this. And the size of the plinth beam is also varying. Its width, it's varying from 230 to 300. So this gives you the layout that, and they are again named PV1, PV2, PV3, PV4, and depending upon the reinforcement, these plinth beams can be cast. And you can see this is a typical section of plinth beam. So what you have here, you have a raft, over raft you have a shear wall, and once you have a shear wall, then you do a bit of a brick wall so as to put the services here. And once so there is a spaces being created in between the shear wall and the plinth to accommodate these services. Okay, and this is how it looks like, and this is a typical detail of your plinth beam, having 4 bars, and these bars are connected to the star. And the shear wall, because it acts as a shear wall, so detailing of shear wall is also very important. If you're doing a project in zone 4 and zone 5, then you may have to design your shear wall as a ductile shear wall. And when you're designing it as a ductile or ordinary shear wall, you have to refer to 13920, and 13920 will typically give you the details that how the reinforcement of shear wall need to be connected through stirrups. And these stirrups play the most important role when we talk about seismic resistance of these shear walls. So all these shear stirrups or shear reinforcement need to be properly bent at 135 degrees. As you can see, this 135-degree bend of shear reinforcement is the most important thing, because if you do it at 90 degrees during earthquake, it will open up. So 135 degrees is very important. The length of this hook is also very important, which is 65 millimeter minimum. Again, it comes from the 13920, or 6 times the diameter. So if dia of this bar is 6, then 6 multiplied by 6, 36, or 65 minimum. So that minimum thing need to be ensured. 135-degree need to be ensured. Wherever you have open ties, then you need to bend it like this. So all this detailing need to be carefully done. And when you have so much of reinforcement, so all these reinforcement need to be tied together to have a box-like action. And so in case of earthquake, all these vertical bars should act together. So that is why they are being tied through these links or stirrups. So all these links, as you can see here, need to be done like this, and all these details are given in IS 13920 and IS 456. So you can see here also, this is one detail. If you have vertical reinforcement like this, how this reinforcement, all vertical reinforcement connected together with the shear reinforcement is shown in this slide as well. So this is a typical reinforcement details of a shear wall, and this is very important because RCC, when we talk about concrete, cannot take any tension. The entire tension is being taken by the reinforcement. And reinforcement, at the critical locations, you need to ensure the ductile behavior, and ductility can be achieved by these simple provisions: the length of the hook, tying of bars, lab splices. This is called development length. So all these are given input. As you can see, a typical shear wall reinforcement up to what height, what is the spacing of shear reinforcement. Then when you are coming at the joint where shear will be prominent, the spacing will be less, and when you are coming in the middle of shear wall, the spacing will be more. So all these things need to be carefully seen and then put in the drawing, and it should comply with the provisions given in various codes such as IS 456, IS 13920, and National Building Code. Okay, so this is a typical detail, and as you can see again, for the sake of explaining you again, you can see this is a typical detail. So this is the PCC, then over that you have raft, over that raft you have that shear wall, and that shear wall, once it reaches the plinth level, you put a plinth beam, and that over that plinth beam you put that wall, and now from here on, this wall is being constructed with this slab using tunnel formwork. So up to plinth you have a conventional, and after over that the entire superstructure is being done with tunnel form and having shear wall and slab system. So you can see here now, I will show you that pictures of the structural system. You can see this is your plinth level, this is your plinth beam, and those are the this is the shear wall which is coming from from below, and then over this now the reinforcement of your walls will be connected. And once you have put this reinforcement, what you can see here, this is that tunnel form, and then you will put a tunnel form here as well, and then do the casting. So this is how reinforcement is being laid, and that what you see here, these are the services. So wherever you have to put the services, you can put the services, electrical cables and all. Then you put a tunnel form on the outer side as well. Wherever you have windows and doors, those locations also need to be, those cutouts need to be put here, and then here also the detailing need to be done, and then the casting will be done. And once you do the casting and remove, you will get these spaces for these doors and windows and other openings as well. So this slide shows you a typical reinforcement details of a shear wall. Now, this slide shows you the reinforcement details of a slab, because once you have reached the shear wall, and then because you are casting shear wall with the slab, so shear wall is also, slab is also very important. The reinforcement details of slab is also very important, and the reinforcement of slab need to be tied with the reinforcement of the shear wall. So you can see here, this is the reinforcement of slab, which is being taken below so as to have continuity. And this reinforcement, which is coming from slab, has to go on the outer side of the shear wall. It will not terminate here, but it will go here. And the reinforcement on the top side, on the top side of the slab will go to the inner side of this shear wall. So this reinforcement of top portion is going on inside shear wall, and this is going on the outside face of shear wall. So this is again a typical detailing which comes from IS 13920, and this is must to have ductile joints and to have a monolithic behavior. So this detailing again can be seen from the structural drawing, and that is why I showed you this drawing. And also continuity of reinforcement wherever you have shear wall is very important. If you are not able to connect these two, if you are not able to provide continuous reinforcement, and if there's a breakage, then you have to provide additional bars. So those details are also given here. Then the details of shear reinforcement, this wherever you have near the end, you require shear at a closer spacing, and in the center you don't require at a closer spacing. So that spacing is also given in this drawing, as you can see. 200 center to center, 400 millimeter center to center. So if you see here at location D, probably here it will be 400, and at location here the reinforcement will be at this location. So this entire thing is being given here, and as you can see, all slabs shall be 160 mm thick unless otherwise specified. So all slabs are 160 mm thick. Their details are given here. Like top reinforcement of slab is 400, it's a 8 mm dia bar, it's a tall steel TMT bar, 400 meters center to center. And these are the locations where you have to put the extra reinforcement. Okay, and wherever there is a beam, so like this is a beam is coming, so these are the details of those beams given. So reading this structural reinforcement plan at slab level, you have to lay the reinforcement cage of the slab. After laying these cages, reinforcement cages, you have to pour, all you have to do is pour the concrete of a specified grade, which is M40 in this case. So this picture shows you a typical this overview where you see all the reinforcement is properly laid for slab as well as for your walls, and now it is ready for pouring, and this is a closure load. And as I told you, always those bars of wall, to create continuity, these walls are taken to the next floor, so that the reinforcement of next floor wall is connected with this reinforcement. And now this is ready, you will do the pouring in a single pour. So in one day, whatever concreting you can do, so that much concrete reinforcement cage is being laid, and then concreting is being done. So this is, now you can see here, this is again a closure look. Here it is being done, and now it is being done here. So through this hose at a pressure, you put this concrete, and this is a self-compacting concrete. So there is no need to do any vibration in SCC or self-compacting concrete is a flowable concrete, this slab is again finished with a smooth surface, and then this concreting is being done. So the entire operation is being done in one day, and so you get the entire unit in a single day operation. So this is how concrete is being done. And now you see how good is the finish. You can see once you have removed the tunnel formwork, this is the kind of finish you get. And these, this is to ensure the thickness of wall. You need to connect, through these holes, the outer tunnel with the inner tunnel. And these holes, then these are removed and these are grouted at a later stage. And at this, I was telling you, this is also very important, this reinforcement, which will be connected with the reinforcement of of the upper walls. Okay, so this is the finished wall, and you can see how smooth and how good is the quality. Now this is again, you see the slab, so you can see this is a perfectly finished slab, and as you can see, the openings for doors, windows, and other openings are left with the frames. These are door and window frames, so this is the entire casting. So this is the finished shear wall and slab after removing the formwork. And then later you do the masonry work. It can be done with anything. It can be brick masonry, or here we are not using brick, red brick anywhere. So it is autoclaved aerated concrete. You can replace it by drywall construction. You can have AAC panel, or you can use EPS panel, or you can use cement EPS panel, or you can use precast concrete panel. So there are a whole lot of variety of drywall panel systems available, but in this project AAC panels are being used, and AAC panels are in environment friendly blocks. Okay, and here the density, and depending upon the application, their density can be varied. So here the density of these AAC panel is 550 kg per meter cube, and again let me tell you that these are being used for partition walls and being used as filler walls, so they are not taking any loads. And this is a very environment friendly block, because it comprises of calcined gypsum, lime, cement, the sand, and aluminum powder. Aluminum powder and cement reacts to give to create aerated concrete, and then these aerated blocks are cured under heat and pressure and in an autoclave. So the curing being done in autoclave, and autoclave is nothing but where heat and pressure is applied to these blocks, so that is why it is called autoclave. So and that is the reason these are called autoclave aerated. And aerated means because through aluminum and the reaction of cement you are creating air inside the concrete, so that is why it is called aerated concrete block. Okay, so once you have constructed beam, your wall and slab, you do this block masonry, and this block masonry, like any other masonry, can be done with mortar, and these are bigger in size, so the walls can be laid pretty fast. The next question comes about the services. So all the services, whether it is plumb, water lines, or electrical services, they are to be put or incorporated before doing the casting of slab and wall. So in shear walls, the plumbing, electrical services, so all services need to be pre-planned and need to be put before doing the casting. It cannot be done at a later stage. So that is for shear walls, and for AAC blocks you can always do the chiseling and chasing, and you can put the plumbing and electrical services. So that was about the technology. So with this, there are other finishing items, and all other finishing items which are being used in other projects or in conventional projects, they can also be used here. So here we are using pressed steel door frames are being used, which I showed you in the previous slide. Then PVC doors are being used wherever we have wet areas, and then for UPVC frame with glazed panel and wire mesh shutters are used for windows. Vitrified tiles and are used for rooms and kitchen, and for wet areas anti-skip ceramic tiles are being used. And at common areas and staircases, rough stone, that is Kota stone, is being used. In addition to this, all infrastructure facilities are being provided in these projects, which include sewage, stormwater drains. Firefighting provisions are must, because it is S+13, so complying to National Building Code. You need to have provisions of firefighting. Also, the shear walls and slab, the reinforcement, their thickness need to have a fire rating as given in the code. So for residential building, it is 1.5 hours to 2 hours rating. So all these structures comply to that fire rating, which is given in code, and in addition, provisions of firefighting are also being given. Also, there are provisions related with renewable energy and sustainability. The STP is being provided. All the lighting, the street lighting is being done with solar energy. And then the rainwater harvesting, solid waste management, BRIHA rating are also few salient features of this project. Few finished buildings, just to make you understand that this technology is also being used in other parts, successfully have been implemented, have been implemented. So these are few completed buildings with this technology. And again, CPWD has also approved this technology, and this is one of the shortlisted technologies in the green, global housing technology challenge. This is a finished project in Chennai with the tunnel formwork. Okay, so with this, I come to the end of this presentation, and you can also access, because you are, if you have enrolled as Technograhi, then you can also access gshtc-india.gov.in website, and through which you can see the live status of each project site. So suppose you want to see the status, what is going on at the moment at the LHV site at Rajkot. So we have installed the cameras, web cameras, and live recording is also being done, so you can have that access. And on a daily basis, the progress of all the projects is photographs of all the sites are being uploaded, so you can see those photographs. And if you want to learn further, you can also visit this website, and you can write to us, and we will pretty soon, once the situation improves, we will pretty soon organize the visits to the site. Also, right now the project is at this stage where the walls are being, wall and slabs are being erected. As soon as the project progresses, I will come back to you with another lecture, with another video lecture. Okay, and if you want to know further anything about the technology, you can always write to us. You can contact us on this address. You can write to the email given here, or you can write to me on a mail, on my email ID, ska@bmtpc.org, and I will try to address the doubts or ideas given by you. Also, we are creating a FAQ, the frequently asked question in a video form for you. So once you have gone through this lecture, you are advised to go through that FAQ, because that FAQ has been prepared in such a form that you will be able to get answers of most of your queries. So with this, I end this lecture, and in near future, I will come up with another lecture. Thank you very much.